Hello. On this pencast, I'm going to talk about graphing the sine and the cosine curve. Let's see. Let's start with the sine function. We started with the sine function when we said that sine of y equals sine of x. And we're going to assume that x is theta. Well, that gets kind of confusing, so let's just leave it as theta for now. Y equals sine of theta. And we're going to get our special points from the unit circle. So we'll draw a circle like this. And we know that from the unit circle, this point is going to be 1, 0. That's at 0 degrees or 0 radians. At 90 degrees or pi halves radians, the point is, this point right here is going to be 0, 1. This point over here, which is 180 degrees or just regular pi, it's going to be negative 1, 0. And this point at 207 degrees or 3 halves pi is going to be 0, negative 1. And we have spoken about sine theta being y over r being 1, so it's just going to be the y value. And later on we'll talk about cosine theta being x over r, or just the x value. But we know that we can just go to the unit circle, and the y value at a particular angle is going to be actually the sine of that angle. So what we're going to do is we're going to sketch on what we're going to consider an x and y axis. And we're going to sketch different angles. So let's sketch 0 radians. At 0 radians, the y value happens to be 0. So we're going to be right there. At pi halves, the y value happens to be 1. So we're going to assume this is 1 right here. So it's going to go up to here. The next angle is pi halves. So we're going every pi halves, or every 90 degrees. The y value is, no, that's x. This one is 0. It's 0, so at 90 degrees, at 180 degrees, or pi, the y value is 0. Then we move on to 3 halves pi, and notice that I'm evenly spacing these angles because the distance between them is pi halves. At this point, the value is going to be negative 1. The y value is negative 1. And last but not least, we make it around a circle, which once again we're going to be at 2 pi. The y value is 0 again. So and what we find is, if when we sketch this, that the sine curve is going to be curvy like this. And the beautiful thing about the sine curve is that it literally repeats itself to the left and to the right. It is fully continuous. So some of the things that we need to know about the sine curve are as follows. The domain is going to be from negative infinity to positive infinity. The range is going to be from negative 1 to 1. How do we know this? Because this is the range right here. X-intercepts. Well, the x-intercept within one full sweep of the curve from beginning to end, we have the curve right here. And by the way, one full cycle of the curve is known as the period. And the period happens within 2 pi. We said the period is one full cycle of the wave. The amplitude is going to be from this here, this line that cuts the graph in half, which happens to be the x-axis, also known as the midline. From the midline to a maximum, or even from the midline to a minimum, it's going to be your amplitude. And the amplitude for this curve is going to be 1. From 0 to 1 is a difference of 1. In order to find the midline, let's say that you have the maximum and that you have the minimum of the curve, then you would do the maximum plus the minimum divided by 2. And that would give you the midline. How would you get the amplitude? Oh, I cut myself into a little corner here. It won't fit. Alright, the amplitude is going to be the maximum minus the minimum divided by 2. Okay? Forget the difference is a plus or a minus, so you have to make sure you remember this. So where does the x-axis, where's the graph, the sine x cross the x-axis? Well, the first intercept happens to be when x is 0, then when x is pi, then when x is 2 pi. At this point we have that the y value is 0. That's where we cross the x-axis. Y-intercept. Well, the y-intercept is going to happen when x equals 0. That's when we have y equals 0, or basically the origin. What type of function? It is continuous from negative infinity to positive infinities. There are no gaps in this function, no holes. The symmetry of this function is going to be odd. Good way of saying this mathematically is that the sine of a negative angle is equal to the negative of sine x. Okay. Maximums. Where are the maximums going to occur? The maximums occur when x is equal to pi halves. That's where y equals 1. And of course this happens every 2 pi. Minimum. Now we're only focusing on the values within one period. Minimum is going to be when x equals 3 halves pi. Y equals negative 1. End behavior. Okay. The end behavior does not exist, because the function doesn't really approach any particular value. It just kind of always oscillates, which leads us to oscillation. Between which values does this function oscillate? It oscillates between negative 1 and 1. Alright, so a quick way of sketching this graph of what I would expect from you, it would be to go from top to bottom. I would expect you to do this. Start at 0. Do your 1, 2, 3, 4, ends at 2 pi. Half of 2 pi is pi. Half of pi is pi halves. Count pi halves. 1 pi half, 2 pi halves, 3 halves pi. And then you know that it's going to go up to 1. It's going to go as low as negative 1. So over here, it'll be maximum crossing, minimum crossing. So there you go. I'll be expecting you to be able to graph this. I expect you to tell me that the amplitude equals 1, that the period equals 2 pi, and that your main intercepts are going to be, your main crossing points are going to be 0, 0, pi halves 1, pi 0, 3 halves pi negative 1, and then 2 pi 0. I would expect you to know those intersection points for this graph.